Well, hello everyone. We got a couple more lessons to go over, and we'll be done with material for the class. This Wednesday, we're gonna do something called data structures. We're gonna see something called nested dictionaries. Nested dictionaries means a dictionary within another dictionary. So we'll see that today. Next week, there's a topic called object-oriented programming. This is one of the biggest features in Python. So we'll cover that next week. It's going to take 2 solid days to cover it. All right. And looking forward, there's going to be a review and catch-up week. So on week 15, if anyone is maybe falling behind on any previous projects, feel free to join us here, and we can go over any previous stuff. If anything, that week will mainly be delivering a practice final. And yeah, once again, the practice final is kind of like the practice midterm. Right? Like several weeks ago, we had a practice midterm. And yeah, it's pretty much going to be the same thing, but with a couple different questions. But yeah, once again, we're headed towards the end of class. Right? Just 2 more lessons. Right? Just pretty much lesson 19 and number 20. We'll be done. Okay, let's jump into data structures though. That's the whole goal of today. There's going to be a lab associated with this, right? So 19, lesson 19 and lab 19. I'm going to start off with a sneak peek as usual, because this can be a kind of a dense material. So let's start off with a small sneak peek. All right, so I'm going to prepare these real quick. The lesson, it's the second to last lesson. It's called data structures. So let me load this one up. This is the lesson and also the lab. So the lab here is the second to last one as well. Lab 19, there we go. Okay, I'm just gonna pre-prepare them. But once again, let me load up a blank notebook to get folks kind of started on what data structures are. Okay, so yeah, let me go into my playground directory. Let me make a blank notebook. I'm gonna call this one a data structure sneak peek. Sneak peek. Okay, data structure sneak peek. All right, before we jump into this, I just want to define what a data structure is. It's kind of like a way of organizing data in a program. We've seen a couple of data structures already. One was a dictionary and one was a list. These are stuff from the very beginning of class. They're ways of organizing a bunch of data into ways that we can access it later. Today we'll see nested dictionaries, a way of combining dictionaries within dictionaries. So just to kind of visualize this for a second, let's visualize what a data structure can look like. For folks who might have worked with something called JSON, JSON is how a lot of data is represented on the internet. JSON stands for JavaScript Object Notation. There's a lot of files that use this type, right? Like how there's something.txt, right? There's something.json as well. JSON is a way of storing data. And how it looks like, a sample of it, it can look like this right here. So this is kind of like an example of a possible JSON representation that describes a profile. In this case, it's a single person's profile. You see how this person's name is John, and then last name is Smith, right? And then there's some key value pairs, right? See how these are all key value pairs? It's kind of like a dictionary. Right? The key, and then here's another key that translates to here. Another key that translates to 27. So this is a JSON representation, right? It's a file of some data. The cool thing about JSON is Python can let us load these into dictionaries right away. For now, I'm just gonna hard code this dictionary into the notebook. So let me go ahead and copy this whole data structure, right? And let's kind of dive down what it looks like. Okay, so I just copied this whole thing. I'm gonna end up trimming it in a bit because it's quite large and hard to look at. So I'm just gonna paste it in here. Right, there we go. I just pasted a dictionary in here. Right there, I need to change a couple of literals. For example, the JSON file uses lowercase true. I'm gonna change this to a capital T because Python literals use capital for the booleans. And then finally, at the bottom here, Python doesn't really have a literal called null. They use something called none instead. Okay, but I am going to end up trimming this to make things look a little easier to read. All right, let me trim this JSON file to like maybe here. All right, let's keep it small. You know what? I'm gonna trim this address as well. All right, let's not care about this yet. Okay, let's keep it simple. This is a representation of a dictionary. Right, so you could store this into something called a variable called profile. Right, so there you go. I just created a variable called profile and then set it to a hard-coded JSON data or dictionary data. So I'm going to go ahead and run this. Right, there it is. I ran it, meaning I loaded the dictionary into profile. So if I were to visualize what profile is now, right, let me take advantage of the Jupyter Notebook showing the last result. So I'm just going to run this and see there's our dictionary. Right? And we can prove it's a dictionary, right? I'll put it in the type. There we go. It's a dictionary. So we can access things inside of it, right? Like we can access, once again, by the key. So one key is the first name. Right? First name, this is going to access the value associated with first name. So this should give us John. Right? And then last name gives us Smith. Right? These are strings, by the way. Right? You can figure it out by putting type in here. Right? So type, I see they're all strings, except for these next two. So let me undo this. Like is alive. Right? Is alive is true. Right? Is this a string? No. Right? We hard coded a Boolean literal here. So this is a Boolean. Let me put a type here. I see it's a Boolean. So the reason why I'm kind of showing the types is because the type of variable kind of lets us do certain operations. Okay, so let's do another type. Let's look at the age. Right, there we go. We just accessed the age, and it's 27. Right, this is, I believe, an integer or a float. Right, let me see. So let me look at the type, and yeah, it's an integer because there's no decimals associated with here. Okay, once again, we're just reviewing like dictionaries. Now, what we did was copy and pasted hard-coded information about this person. This is from the wiki, by the way. So let me bring back in another key value pair. Right? Currently, the length of the dictionary. Right? What do you think the length of this dictionary is? Like if I did the length of profile here, let me use a new cell. Let me do a new cell. Length of the dictionary. Right, what do you think the length is? It's 4. Right, there's 4 key value pairs. Okay, but let me add in another key value pair. The original data that I copied, right, I ended up trimming. Let me bring back one more value here. Whoops, let me redo that. Now let's say I added in another key value pair, like over here, the address. Let me just copy this over. Okay, so I just pasted it. Oh, let me fix the indents here so it lines up. Okay, hold up. This is unformatted. There we go. Looks a little neater. Okay. I just added one more key value pair. It's just this thing that I highlighted. Right? We have a key called address, and then the value is another dictionary. So this is kind of a nested dictionary, right? We have a dictionary as a value inside of this profile dictionary. Okay, what do you think the length is now? All right, let me run this cell. Okay, I just ran it, so Now my profile is different. What do you think the length is going to be if I run this? Right, earlier it was 4, right? Because we had 1, 2, 3, and 4. Now what do you think it's going to be? So I'll rerun it. Right, it's 5. Right, there's 5. So the reason why I wanted to show this is because some people might think it's like 10. Right, some people might say 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, some people might say 9. Right, but this is nested. Right, the length of the dictionary is defined by how many keys are on the outer dimension. So there are 5 keys in the outer dimension, right? 1, 2, 3, 4, and 5. Right? Just 5. So you can kind of ignore this stuff right here and just imagine that there's something in here. Right? You don't have to know what's in here yet. So yeah, hopefully that makes sense why the length of this dictionary is 5. Okay, so the length of the profile is 5. Let's go ahead and see what happens if I access that key value pair. Like we just added a key value pair called address. So if I put in address here, right, what do you think it's going to return? So we're accessing address, meaning that we're going to say, hey, what is the value associated with this? Yeah, it should return like 4 different things. These 4. So let's see. Yeah. Right, so see what's happening here. So profile address, it gave us a whole new data structure. Right? It's not a single thing. Right? Like earlier, we were able to access single values, but now we're kind of diving into another one. So let's see what the type of this is. Right? The type of this value is another dictionary. So the takeaway here is we have some nesting here. People kind of see that we have a dictionary within a dictionary. Yeah, it's pretty cool stuff, right? It's how a lot of data on the internet is organized. In particular, a social media kind of a lot of those companies, they'll store your data like this. This way, it's easier to load into programs and make predictions based off of it. All right. So let's kind of learn how to navigate this dictionary, right? Like, what if we wanted to go inside of this? So we did verify this is a dictionary, right? We put the type around it. It is a dictionary. Let's see how to navigate, right? Like if we were to access this street address, right? Well, we would just have to index again, right? So I'll put index another set of square brackets, right? And then street address. Right, so this is going to look a little tricky, right? And there we go. We finally return one single thing. Right, so there's kind of 2 things happening here, right? One is here, right? We're accessing a dictionary, and then next we're accessing the key in that dictionary. So let me just comment this real quick. This is accessing a value in a dictionary, right? in a dictionary that's inside another dictionary. Right, so people kind of see that, right? We access the address and then go into the inner dimension, right? The inner dimension would be street address. So we're pretty much going address, and then we're going inside and grabbing this next key value. Again, we can access other things too, like city, state, and postal code, right? Like if I put the city here, let me go ahead and print it. Let me print it. Okay, so we can access the city, the state, right, and then the postal code if you want. Postal code. There we go, right? Yeah, hopefully people kind of see what's happening. Accessing values. Are people cool with nested data structures so far? Okay, we're just keeping this small for now. We did trim this data. We could go into more detail, right? Like the original data was from here. Right? We could grab in some more data here if folks want. But I'm not going to paste these in yet because we're going to see this in the lesson. All right. Cool. That's a little sneak peek right now. Just the goal of this sneak peek was to navigate a nested data structure, which is a way of storing and organizing data in a computer program. All right. Okay, with that in mind, let's go to the lesson. We're going to do a piece of the lesson and jump into the lab. In particular, we're going to go all the way down to this web API, and then we're going to move on to the lab. So we're going to kind of switch back and forth a bit. All right. Cool. Let's do the same thing. Right? So the first thing we should do here is it's the same scenario, right? It's someone's profile. So imagine this as a dictionary of someone's profile. Right, I'm going to paste it real quick. And there we go. We have the name and then the values. Mike, right? Key email goes to here. Right, so here, let me go ahead and play this cell. Cool, there we go. I played this cell, meaning I loaded the data into a dictionary variable called contact. And then let's once again access things. Right? We did see how to access things in the sneak peek, right? Like if we wanted to access the name, right, then we would just say contact name, right? Because we're in the outer dimension, so this is going to return us a Mike, right? And then email, right, returns us this value here. Okay, but what if we were to access individual things inside of here? Right, this is another key value pair, but the value is a dictionary. So yeah, let's kind of see what's happening here. All right, what if we were to print out this work here? Right, well, we'd have to dive into this phone dictionary first. So let me dive into this phone dictionary. Right, we would have to say contact phone, right, and then this gives us another data structure. Right, once again, this is a dictionary. Right, let me verify with a type. I see it is a dictionary. All we need to do now is dive deeper. Right, this is a dictionary, so we just have to index one more dimension. Right, in this case, we're going to go into the work. Right, and it'll finally access this inner value. Right, 55, and this number right here. Okay, and let me just go ahead and print this. Okay, cool. Hopefully people are cool with this so far. All right, all we did so far is declare a nested dictionary and then learn how to navigate to the inner dimensions. All right. Let's do some loops. All right, sometimes it's necessary to loop over data structures because you might have larger ones. This is a pretty small one. Let's say we had a larger one, like contacts. Right? So instead of singular contact, right, let's say we had a dictionary of multiple people. It's going to be a different organization, by the way. But basically, down here, right, you see how there's two contacts now? Right? This is pretty much a different organization. It's got kind of another layer to it. Right? If folks are wondering what's happening here, we're pretty much taking the previous data structure and inserting it into another one. Right? It's going to be plural contacts, though. So let's see. Yeah, here, let me just build that from scratch. Right? This is like saying, copy. I'm going to copy this over here. All right, so let's create a new dictionary. Right? It's going to look like this. It's pretty much right, contacts, plural. We're going to say it's a dictionary, but we're going to insert a single person in here. Right, let me insert Mike. So let's say that the key is associated with Mike here, right? And then the value, right? The value, I'm going to make it another dictionary. Right? It's going to be the dictionary that I just copied from here. Right? So this stuff that I highlighted, I'm going to treat this as a whole value. So this is going to look a little tricky because I'm going to declare it as a data structure, a dictionary. So I'm going to say Mike's value gives us another dictionary. So let me paste some data into this dictionary. Boom. And let me tab some things to make it lined up correctly. Okay, let me tab this. The reason why I'm tabbing like this is so we see what belongs inside what, right? Like this curly brace lines up with Mike, so everything in here belongs to him. All right, so we just inserted one person here, right? There's some triple nesting here, by the way. Right? The outer dimension is the person. Right? The inner dimension of that is that person's profile, and we have another inner dimension, right, inside of this phone. So there's kind of 3 layers of nesting going on here. The reason why we inserted another layer of nesting is so we can add in another person, right? Like if we were to add in, here, let me get a comma here. Right, we need a comma after every key value pair, and this is technically a whole value. It's a whole dictionary value. So let me do a comma here, and then add in one more contact information. Right, in this case, I'm just going to put Nora. Okay, so let me build this from scratch so people kind of see what's happening. Right, so there's another key value pair. This is a Nora, and Nora has a value associated with it, a dictionary value. So let me populate this dictionary's value. So let me press enter here. Right, in this case, we're going to redundantly store its name. Right, the name is going to be Nora, right, and then let me do a comma, right, because this is a key value. Comma enter. Nora has an email, right, and in this case, we're just going to use here nora@nora.com. So nora@nora.com, and then we have a layer of nesting here. We have a phone key value pair, but this value is going to be another dictionary because you can have multiple phone numbers. So there we go. I just declared another layer of dictionaries, and let me enter here, and let me insert a couple of things, right? There is going to be a work number associated with it, and I'm just going to copy these over. Let me copy this. There we go. All right. Cool. So we have a more complicated data structure. It's what do you think the length is going to be? So let me run this. Let me run this cell. Okay, so I just ran this contacts cell. Oh, what do you think the length of contacts is? Like how many key value pairs are in the outer dimension? Yeah, it's kind of hard to say. Yeah, it's 2. 2. Yeah, it's a little hard, and you can verify that right here. Right, if you do like a length of contacts, right, it's 2. Right, the reason why I was asking that is because folks might think it's a different number, right? They might say, oh, it's 1, 2, 3, 4, 5, 6, right, and keep counting every single thing. Right, but once again, this is a nested dictionary. When we do the contacts one, it's looking at how many key value pairs are in the outer dimension. Okay, but let's go ahead and access things inside of it. Right, like let's go ahead and write some loops. All right, you might remember from a few weeks ago, we can loop through dictionaries. Like when we loop through dictionaries, it's going to go through all the keys. So let me just bring up the previous lesson so folks are refreshed. So this is a for loop lesson. You might remember that when we iterate through a dictionary over here, right, the sequence is going to be all the keys. So let's go ahead and do that. Let's write a loop. So our dictionary is called contacts. So let me write a loop for something in contacts. Right? There is a better name for something, by the way. It's probably it's probably better to name it like name, because when we iterate through a dictionary, right, we're going through all of the outer dimension keys. So let's see what the outer dimension keys are. Right? This is the Mike key and this is the Nora key. Right? So you could call it contact or you can call it name. I'm going to call it name for now. Actually, no, I'm going to call it contact just because I want to keep it consistent with this example over here. You can call it whatever you want. I'm calling it contact, a singular. Okay, and this does go through all of the keys. So let me go ahead and prove it by printing out the keys. So let me see. I'm going to say iterating, or I'm going to say name. Name and then contact, right? This way we're going to print out every single key. And let's kind of see what's happening here, right? We're iterating through the outer dimension, and there's only two keys, right? Mike and Nora. Okay, let's say we were to kind of dive into these values though, right? Like Mike has a dictionary attached to it, and Nora has another dictionary attached. Right? You can scroll up and see that. Right? Mike has this whole dictionary attached to it. So let's kind of dive into it. Let me do the same exact loop, right? But we're gonna access each individual thing inside of it. So let me do the same loop for contact and contacts. Now let me go ahead and print the name out again in a different way. I'm not going to use an F string this time. I'm just going to do this example here. Okay, this is not an F string. We're just going to use a comma. Okay, so we're back to original. Right? What if we were to print out their information? Right? We would have to dive into the dictionary, so we can kind of access that. Right? Well, so the dictionary is called contacts. Right? We need to dive into the key. Right? The key is represented by this contact here, not a singular. I mean, not a plural. So make sure not to have both s's. Right? The dictionary, the outer one is a single s. I mean, is a plural, and then the inner one is singular. Once again, we're saying, hey, grab the name here. Right? Okay, I guess we could name things a little differently to make it more readable. Maybe I could put name here, name here. I guess this is a little more readable. Right? For name and contacts, right? For every key, we're just going to access it, but we need to dive into it. Right? This line is accessing the dictionary. So let me just print this for now and then fix it in a bit. Okay, so let me just print that. Right? You kind of see what's happening here, right? Every loop iteration, we're printing two things, right? The name, and then next is the whole dictionary attached to that person. Right? If anything, it might be more readable to kind of specify this second line, right? Like if we were to access this email, right, we'd have to jump into the inner dimension, which is with another set of square brackets. So this other set of square brackets, I'm going to put email here because that's the name of the inner key. So we're accessing the inner dictionary, and let me make this print statement nicer. Okay, there we go. All right. Yeah, people kind of seeing what's happening here. It's a little tricky to see. All right, once again, all we're doing is iterating through this data structure, right? We went through Mike's data structure and only accessed one thing. And then we went through Nora's data structure over here and then accessed that one email. Okay, let's see what else we should do. Okay, here's the kind of tricky part, because each of these people have multiple numbers attached to them. So what if we were to expand this and print out those phone numbers as well, right? Like each of them, they have like an office phone number and a mobile phone number. We'd have to do another layer, right? We'd have to dive in one more time into the phone key and then iterate through all of those key value pairs. Right, so we're gonna end up having a for loop within a for loop. Right? The one for loop will go through the outer dimension, and then the inner for loop will go through this inner phone dimension. So it's gonna look a little tricky, but hopefully it's kind of readable. So let me go ahead and copy this because we're gonna end up expanding on it. Okay. Okay, so once again, our goal is to print out all of their phone types. Like under here, let's say our goal was to print out all their phone numbers. Like we would have to dive into their phone numbers. Right, so how do we access their phone numbers? Well, scrolling up a bit, right, we'd have to look at the outer key, and then the inner key is phone. So let me do that real quick. Okay, cool. So let me get that in here. Right, so we'd have to grab that phone dictionary, right, which is contacts name, right, and then we have to dive into phone. Okay, so this line is accessing a dictionary. So here, let me, sorry for scrolling up and down a bunch, but this whole line is kind of saying, it's kind of saying go through the contact name, right, and then access this phone value. So we're going to end up accessing this whole dictionary here. Right, that's what this line right here is doing. All right, and just to kind of prove it, right, let me print it out real quick. Right, let me print it out. Let me put a bunch of spaces here real quick, just so we can line up with the email. Okay, so let me just print this. Okay. All right, yeah, so people kind of seeing what's happening here, right? For all the naming and contacts, right, we're printing out the outer key, we're diving into the email, and then this last print statement is accessing a whole dictionary. So this last line in the for loop is printing out this dictionary and this dictionary. So yeah, we could just print it out like this, but it might be more nicer if we format these. So this means we're gonna have to do like a nested loop, right? We basically have to loop through this piece right here, right? This once again is a dictionary. So this is gonna look tricky, right? Because we're gonna end up writing a loop, right? In this case, we're gonna iterate through this dictionary here. So I'm gonna iterate through it, right? So for something in this whole dictionary, and then a colon. And let me comment this print statement out. That was for visualizing. For something, what's a good name for something? Well, this something is representing work and then mobile. Right, so a good name for this something would probably be a phone type. Okay, and yeah, make sure you get your indents right. Here I'm making sure that the for loop is inside of here, right? So make sure there's an indent. This way we don't have separate loops, right? We want this loop to be inside of one. Okay, so this loop is saying, hey, go through the work and go through the mobile. Okay, so let me just print out the phone type real quick, just so people kind of see what's going on. Phone type. I'm just iterating through. You don't have to type this print statement out. I'm going to end up deleting it in just a bit. Phone type. Yeah, this is just to visualize what's happening. Oh, let me put a space here, make things look nicer. Okay. So there we go. I just press play. All right, so for each person, right, for Mike, we're doing a nested loop. Right, you see how there's a loop within a loop? So it looks a little tricky. But yeah, we're doing this for Nora as well. So let's use this phone type. Right? This is the phone type. This is a key. Right? We can use this key to access the value. Right? Once again, the value is over here. Right? You see how the key is this phone type? Right? We can use that to index the value here. Okay, so let's go ahead and edit it. Let's see. So once again, we just need to use this phone type. Right? Like we need to maybe use this as a key inside the dictionary. So this is going to look a little tricky because now we're going to have 3 layers of dimensions here. Like if I were to print out their phone type, right, I would just access this dictionary. Right, so I just pasted this dictionary here. Right, this returns us a whole dictionary. So I need to access the key. Right, the key is phone type. Right, we just printed that out right here. So now this should be returning a single value. Right, like let me go ahead and print this whole value out, and then delete this over here. Let me put a space in between, make things look nicer. All right, kind of see what's happening here. Okay, yeah, hopefully people kind of see what's happening. Let me just look nicer. There we go. Okay, yeah, so we're printing out each of their phone numbers here. If anything, it might be nicer to label it, like maybe maybe here I'll just print out phone type, and then a colon, just to make things look a little neater. All right, see how it's a little neater now. We prefix each number with this phone type over here. All right. Cool. Yeah, so this does look a little tricky, but the takeaway here is we have a for loop within a for loop. Right? The reason why we might need that is because the inside, the inner dictionary will have multiple things in here. Right? And what the cool part about this is we can keep adding to these contacts and it should still work. Right? Like let's say Mike had another type of phone. Right? Let's just say they had like a home. Right? Let's say they had a home phone, and I add in like another number, like 1, 2, 3, 4, 5, 6, 7. I'm just making up some numbers. So all I did here was add in a third number for Mike. I'm not going to add one for Nora. Our for loop will handle this for us. So let me load this new contacts in. Right, there we go. I just loaded this in. So if I were to play this data structure again, this iteration, right, you see how it updated? Right, you see how the inner for loop handles that dictionary for us? Right, it's putting out this new one, right, this new home. Okay, cool. Hope that makes sense so far. Okay. Yeah, there's some cool stuff. Okay, let's see. Okay, with this in mind, we should have enough to do the first part in the lab. I'm not going to go over web APIs yet. I'll do this right after the part 1. So let me go to the lab and help folks get started. Okay, lab 19, data structures. All right, the point of this lab is really the same thing. All right, we're going to be navigating through a contacts data structure again. Okay, this first part is asking us to load in a file called address book. So this is kind of non-trivial, so I'll help folks get started on this very first question right here. It's asking us to build a dictionary from a file. Right, like we have a file here, by the way. It's inside of the labs directory, I believe. So let me go to labs directory and files. There we go, labs files, and then address book. But there is a file here with 4 lines. Right? Imagine we downloaded some information and we have this file. Right. Well, the first part in the lab is asking us to read from this file and store it into a data structure. So once again, this is non-trivial, so I hope folks get started with it. Okay. So it's asking us to create a dictionary called address book, right? But in this case, this is just an example, right? There's only one person in here. There's only one key value pair. So I recommend not hard coding this address book, right? Like some folks might copy this into here, right? They might copy the address book into here and then add in the second person, right? Like here, don't do this because we're gonna do this a cooler way. So some people might say, hey, address book is this, let's add in another one. Right, let's add in Sally, right? And then Sally has another dictionary, right? Once again, please don't type this because there's a neater way we can do it. Right, so some people might put in like, oh, mobile. Mobile is this number here. So I'm just going to store that here. And then office is over here. Right, this is Sally's office number. And then the email, right? The email would be sally@example.com as a string. The reason why I recommend not doing this is because we're technically hard coding data. And this first part of the lab is kind of asking us to read from the file instead. Right, it says read the file line by line and kind of populate a dictionary from it. Right, it's better to do this way because then we can work with any text file. Right? If we just hard code the data into the cell, then it's gonna be the same result every time. Right? In the future, we might have like a different address book. So let me delete all of this stuff because we're technically hard coding something. I want to keep it as empty for now because our goal will be to populate it. So this is going back a lot of weeks. Basically, we need to read this file using Python. Right? Folks might remember we can open files and read things line by line. So let's do that first, right? Let's load in this file and read it line by line. Okay, let me see. I'm gonna exit this address book. Okay. So we have an empty dictionary. Our goal is to populate this with data from a file. We do need to open the file, right? You might remember this from a while ago. There is a function called open that takes a file name. Right, in this case, the file name is files, and then address book. And I think it's addressbook.txt. Right, let me verify. Yeah, files addressbook.txt. Okay, this will open it. I'm going to open it up in read-only mode. You don't have to use this R flag because it's the default behavior anyways. But yeah, this opens it. It does return a file handle, so we should store it. I'm going to store it into a variable called file handle. Right. And yeah, as a good programming practice, make sure you kind of close things. So at the bottom of here, I'm going to say file handle.close. This way we don't have too many open things at once. Yeah, we're gonna do stuff in between. Okay. We opened up a file, right? This is like saying, hey, Python, open up this file, right? So there we go, right? Python opens it up, and now we just have to kind of parse it line by line, right? We need to go through each line and grab some data and then insert them into the dictionary. So yes, let's start with step one. Let's grab each line one at a time. Right? There are multiple ways on doing this. If folks are familiar with reading files, right, you can use the file handle .readLine, right, or you can actually iterate through this file handle as well. And so some people might do something like file handle .readLine, right, and they might put this in like a for loop, right, but I'm not going to use this. You can actually just iterate through this file handle, right? Like from the previous for loops lesson. Let me bring it up. In a previous for loop lesson, you might remember that we can iterate through a file handle, which will give us every single line in that file handle. So let's do that, right? Let's just write a for loop that goes through. So for something in file handle, let's see. For something in file handle, right? Once again, the file handle is a sequence of lines. So this something variable might be better represented as line. Okay. Cool. So we're going through, and for now, I'm just going to print it just to sanity check things. So let me print looking at line, or I'm going to say parsing line. And let me use an F string here. This is just a sanity check print statement. It's to help us visualize and make sure we're going through the right file. So let me play this. So press play. Okay, cool. There we go. Okay, see what's happening here? Right, we wrote a loop that iterates through the file handle, and all we're doing is just dumping out the data. Okay. Cool. Here's the tricky part. We're going to need to split this data up into pieces. So this is actually a whole string. All right. Once again, the goal of this first part is to kind of make a dictionary that looks like this over here. Right. This is an incomplete dictionary. There will be more contacts in here. There will be 3 more contacts. But we need to split that line into little pieces. Right. Like we need to grab the first part, put it as a key. We need to grab the next data and put it as the values inside of a dictionary. So let's kind of work on that. This is the tricky part, right? Like each line, we need to split it up somehow, right? So this is a whole line. We need to split it up based off of this delimiter here, right? It's a comma and space. Right? You see how every data value is separated by a comma space? Right? Python comes with a string function called split. So we could actually split things. If we do a line.split, so we could do a line.split, right? And split it based off of comma space. So let's kind of see what this does, right? Let me print it out. This technically returns us some pieces. So I'm gonna name it parts. Right, parts. Basically, this will give us a list of strings. Right, let's visualize it. So I'm gonna print parts are parts. Okay, so let's kind of see what's happening. Print, press play, and I got an error here. Unhashable type list. So I think I meant parts. What do I mean here? line.split unhashable. Got a little typo here, right? We failed on this line here. Oh, you know what? It's because I messed up my f string. That's my bad. So I didn't mean to have this comma here. It should be within these double quotes. So let me put those double quotes here. Yeah, all I did was mess up the f string. That's all. So yeah, here's a single string, and we're interpolating a list here. So let me press play. Okay, let's see what's happening. So it's a little hard to read right now, but there's 4 lines in this text file. And in each line, we're kind of doing 2 things. All right, we're parsing the line, and we print out the parts. Right, you see how the parts is a list of items. So basically, we took a single string, right, and then split it up into a list of different strings. And that's what's happening here, right? We split based off of this comma space. Right, if the folks are wondering what the split function does, we covered it a long time ago, but I'll bring it back up. Right, it's a string method in Python. Right, let me pull up the documentation. Oops, that's not the primary. Right, string methods. There's something called a string.split. Right, this is documentation. Right, it's a function that returns a list of words in a string, right, using a separator as a delimiter. So this means that the separator we're using is a comma space. Right, we're saying split the whole string, but every time there's a comma space, we have a token. A piece on the left and right. So yeah, that's a split function, right? It's saying, oh, split this, right? Split over here, and split over here. So that's kind of why we're ending up with these 2 parts. But you might see this garbage new line here, right? That's why our output looks kind of ugly. You might see that there's a hidden new line at the email. Right? You see this /\n. Right? This is saying there's an n line at the end of every line, which is why we're printing out a blank line over here. Right? Because the first print statement will do an n line for us, but the file already has these n lines. So we could get rid of this. Right? One way you can get rid of it is by doing like a line. It's called a strip. Right? Like you could pretty much do something called a strip here, right? Which is a string function that removes new lines by default. So I'm gonna put it here, strip as well, and then rerun this. All right, you see how it's much neater now? Basically, all the strip function did is it removed the new line, the trailing new line. You can look at the documentation for this, the strip. Right, it returns a copy of the string with the trailing characters removed. And yeah, by default, it's going to remove the new lines. Okay. Cool. So let's kind of summarize what we did. Let me do another print statement here just to make things look nicer. If anything, I'm going to put an extra new line here. Make things look a little neater. Okay. So we're kind of just talking about how to parse data. Right? Currently, we're going through 4 different lines. Right? We're cleaning up the line. Right? First, we stripped the new line, the trailing new line, and then we split it up into parts. Right? That's what's happening here, right? The parts is being split into 4 separate pieces. This is a list. Right? You see these square brackets. Right? You can verify as a list with the type function. Right? You can just wrap this in a type, and right, you don't have to do this. I'm going to put this in a type just to prove that it is a list. All right, so I just reran it. Right, see it is a list, meaning that we can access individual elements, or we can access this first element and insert a key value pair. Right, we can access the next elements and insert those later. So here, check this out. Currently our whole goal is to populate a dictionary, right? This address book. Our address book is currently empty. Right, so let me just run address book here. Right, see, it's empty. Let's go ahead and start populating. So we need to use these parts, right? Like this part is a list. The first index represents the name, right? The key that we want to insert, right? It's representing this first one. And then you might see that the value is another dictionary. So basically for every name, we need to insert a name and another dictionary. All right, so here, let's grab the name first. All right, so we can access the name in the first index of parts. All right, parts 0. All right, this is saying grab the name. So this is going to grab Mike here. So here, let me store this in a variable called name. This way our code can look more readable. So I'm grabbing the name. And if anything, we just need to create an entry to the dictionary. Right? Our original dictionary is called address book. And you might remember that we can insert things into dictionary just by creating key value pair. Right? So I'm going to create one by saying address book of name. Right? And I'm going to set it equal to an empty dictionary. All right, so yeah, let's see what this Let's see what this is saying. This is saying grab Mike, right, in this name, and then we're going to insert a key value pair. Right, so let me just comment this. Inserts a key value pair. Right, the key is name, and the value is an empty dictionary. Okay, so that's what we're doing here. Let me run it. Okay, there we go. We ran it. Right, there are some print statements here, but let's go ahead and visualize what the address book looks like. So scrolling down, I'm going to rerun this cell, which will show what the result is. There we go. Right, you see our address book now has 4 key value pairs. Right, the first key value is Mike, and then it's got an empty dictionary, right, Sally, and then another empty dictionary. Right, so pretty much we're trying to build this address book here. Right, once again, this address book is incomplete. Right, you can assume that there's going to be more people here. Right, we got Mike, we got the other 3 people inside of this same one. So yeah, we're setting it up. Right, we're almost done. If anything, we just need to populate these inner dictionaries. Right, what do we need to populate it with? We got to populate it with this data over here. Right, like their phone numbers and their emails. So let's see what we need to do. Right, this inner dictionary will have 3 more elements. So let's kind of take a look at it. Right, we need to create a key value pair for mobile, right, another key value pair for office, and another one for here. So let's create 3 key value pairs that's inside of this dictionary. Okay, so this is going to look a little tricky, right? Like basically we need to say something like address book name, right? And then we're diving into another dimension. We need to dive into this dimension here. In particular, we need to access mobile. Right? We're going to create mobile, office, and email. So let me get that here. Mobile is equal to something. And then let's get the office and email as well. All right, so there we go. These 3 lines are attempting to access this inner dictionary. In particular, we're going to create 3 more. All right, let me just set it to dummy variables for now. And this way we can fill it in later. Testing. Let me put testing here, testing here. All right, we're going to fill these in later. I just want to build things up step by step. So let's run this. Okay, there we go. And I'm going to comment out these. I'm going to comment out this first line. Okay, so let's look at the address book now. Right, you kind of see what's happening. Basically, we started populating the inner dictionaries. Right, earlier, each of these were empty, but now they have something in it. Okay, so we're almost there. If anything, we need to change these testing strings to the actual value that we're grabbing. These values are stored in the parts. Right, you see how these parts, there's 3 more elements? Right, we can just grab the next elements. Right? I mean, one way you can do it is just say parts 1, right, and then parts 2, then parts 3. So this is saying grab each part and insert it to this dictionary over here. All right, let me play this. There we go. Just press play. And let's look at our address book now. So looking at the address book, and there we go. We populated it. Right, basically, we have 4 in the outer dimension. Right, we got Mike, Sally, Lucia, and then Mo. But then the inner dimension, right, is this other whole dictionary, right, which contains 3 key value pairs, right, mobile, office, and email. Right, so another way you can look at it is like over here. Right, you see the dimensions, right? The outer dimensions represents a single person, and the inner one represents all of their data. Right, yeah, so this is a little tricky to look at, so let me comment this. This is inserting a key value pair inside of the inner dictionary. Right, basically, we're saying, hey, look at the inner dictionary. So the inner dictionary is address book name, and this next piece is saying create a mobile key, right, and then set it equal to the parts, which is this over here. So I hope that makes sense what's happening with this address book. All right, once again, the length of this address book is 4. There's only 4 key value pairs. Okay, let me leave this up for a bit so folks can copy it down. Yeah, I got some errors. Yeah, let me take a look. Pause the recording here. Okay, now that we have this dictionary populated, we can work on the next part in this lab. Right, the next part, this is asking us to kind of navigate the dictionary and use some loops. Right, I'll let folks give some time. I'll give folks some time to try this out. Right, so see if you can do number 2. You don't have to do number 3 because we didn't cover something called input. So we'll do this in just a bit. But yeah, see if you can at least do number 2. Right, number 2 is asking us to iterate through the address book dictionary and print out something that looks like their information. Right, so pretty much our goal is to iterate through this whole address book, right, and then access every individual person. Right, so in this case, this is only printing out the first person, right? It's accessing Mike and his mobile right here. Right, the goal is to write a loop that goes through everyone. Right, so it's going to print out Sally, and then Sally's mobile, and then print out Lucia, and then that mobile as well. and keep going on. So see if you can write a loop that goes through that. It is going to be a tiny bit tricky, but hopefully people can give it a shot. Yeah, give it a shot. See if you can do that. All right, we'll give it like 10 minutes. And once again, we don't have to go over number 3. We'll do that together later. Cool, all right. Hopefully people give that a shot. Let's try this out together. Our goal is to write a for loop that prints out every single contact. Right? So this is incomplete. This is just an example of the very first line. If anything, we need to iterate through the dictionary. Right? The dictionary is called address book. Right? So let's do for something in address book. A better name for something is the key. Right? When we're iterating through a dictionary, right, it's going to go through the outer dimension. Right? So this is a key, and then here's another key, Sally, right, and then Lucia and Mo. Right? So it's going to go through 4 keys. Right? It's not going to go through these inner ones because these are the inner dimension. Right? So hopefully people see that. Right? There are 4 keys in the outer dimension. So a better name for something is probably like name. Right? For name and address book, I'm just going to print out this for now, right? Like contact and then the name. So I'm going to print out contact and then the name. Let me use an F string. Okay, name is the key that we're iterating through. So let's see. Okay, there we go. Right, we got a piece of the print statement working. We got this piece working, the contact and the name. If anything, we just have to access the inner dimension. Excuse me. We just have to access the inner dimension and get their mobile number. And so how do we do that? Right? Like imagine if we were accessing the value attached to Mike. Right? This is another dictionary within itself. Right? A dictionary with 3 elements. If anything, we just have to access just one thing in here. Right? So here, let's focus on accessing this first dictionary. Right? The way we can do that is just by indexing the key. Right? Like if we were to here, let me add to this print statement. Right? We're gonna print out mobile and then something in here. Right? If anything, we just need to grab that whole dictionary. Right? So the whole dictionary is address book, but indexed at that name. Right? So this is saying grab the value attached to that person. Right? And once again, that value are these dictionaries. Right? This one right here, it's going to grab Sally's dictionary. It's going to grab Lucia's, right? And then so on. So here, let me just play this real quick and then edit it. Okay, cool. We're almost there. All right, so we printed out mobile, but then this next piece is their whole dictionary. Right? That's not necessarily what we want. We need to dive in and grab the key value pair, right? The mobile key. So we're gonna have to add another set of brackets here, right? Another set of square brackets and grab the mobile value. Okay, cool. There we go. So the takeaway here is we dove in it twice, right? This first piece, address book name, this is grabbing a dictionary, and within that dictionary, we're asking for the value attached to the mobile key. And so that's like saying grab this first piece and then look for the value attached to mobile. So it's going to go to mobile and then grab the value attached to that. Okay, hope that makes sense what's happening there. Okay. Let's do this third part together. This one I didn't expect folks to do because we really didn't cover the input function. We kind of did cover this, but very quickly. We did this in the while loops. So if folks want to look back at the while loops recording, right, it's a while ago. It was a while ago in the yeah, about 14 days ago. So yeah, you could look at the while loops. We covered something called the input. And pretty much what this function lets us do is lets the user type in something. Right? Like this one is asking, hey, ask the user to search for a contact. Right? So this is saying prompt the user to type something. So there is a function called input in Python. Right? Basically, the argument is the prompt. Right? Like let's say the prompt is, who do you want to find? Who do you want to find? Right, so who do you want to find? I'm going to press play here. Right, the cell is still running, by the way. Right, we're stuck inside of the input function. Right, it prompted the user, who do you want to find? And then when we type something, it should finally return something. Right, like let's say if I type in a Mike, then enter. Right, it finishes this function. So let me run it again. Right, enter. I type in like Andrew and press enter. Right, so that's what the input function is letting us do. If anything, this does return a string that we should capture. Right, like the whole goal of this part is to capture their search, and then use that capture to look through this whole dictionary here. So this function returns a string. Right, I would call it like query. Right, this means that whatever we typed in will be stored into this variable called query. Right, so let me press play again. Right, press Andrew. Right, this press enter. Okay, it didn't look like it did anything, but it did load the Andrew string into query. Right, if I run it again, type in Mike and enter. Right, now query becomes a string that represents Mike. If anything, we need to implement this part now. Right, if the contact exists in address book, then print their contact. Right? If they don't exist, then print not found. So you might remember that we can use some Boolean operators in dictionaries. Right? Like remember the in keyword? Right? The in keyword returns a Boolean. Right? Like we could say something like query in the address book. Right? This is kind of returning a true or false. Oh, someone is getting an error. Hold on, let me pause the recording real quick. Okay, let me start recording again. Okay, let's see. Okay, once again, you might remember this in keyword that returns a Boolean. In this case, the Boolean represents whether or not this key exists in the dictionary. So here, let's test this real quick. Right? Let me see if Andrew exists in here. Right? Andrew, nope, it's false. Right? That's because there is no key Andrew in this dictionary. Right? We only have 4 keys: Mike, Sally, and Lucia, and Mo. Right? So if we were to try it again, right, like with a Mike, right, let's see Mike. Right? See, it's true. Right? This is true. So we can use this condition and finish the rest of this. Right? If the contact exists, then we should print out their contact info. Right? We can use this as a condition, meaning we can put in an if statement. Right? So if this is true, then we can go ahead and access their information. Right? Else, we're going to print not found. Right? So for now, I'm just going to do the true part. Right? If they do exist, I'm just going to print their information out for now. Right? Once again, query is a key, so we can access it by indexing the address book query. All right, query is a key, so let's test it. All right, so who do you want to find? I'll type in like Mike, right? And the second I press enter, this statement should finish. And then we'll jump down to here and see if this is true. Right? In this case, this will be true, so we're gonna dump out some information. Right, enter. Right, see, and then it printed out his information. But if we try it again and type in like Andrew, right, nothing happens. Right, nothing happens because this is false, right? It's false, so we don't execute the body of this statement, right? We have to handle the other case, right? If they don't exist, then print not found. Right, so this is the else case. So else, right, else is the opposite of this first one, right? If this one is false, then we're going to jump down here and just print not found. Okay, let's test it. So who do you want to find? Let's go Andrew, enter, and it says not found. Right, that makes sense. Let's try it again. Let's go Mo and enter. Yeah, Mo is found because this person is a key in the dictionary. Okay, people cool with this so far? All right, cool. By now, we should be comfortable with navigating through data structures. I understand it is a bit tricky because of multiple dimensions, but yeah, make sure you're comfortable with navigating through these sorts of dictionaries. All right, that's the whole point of this first part. All right, let's do one more piece and we'll be done. So I'll jump back to the lesson. It's gonna talk about web APIs. Right? Web API is code that a person releases so you can use their software. In particular, we're gonna use a Wikipedia API. So here, let's jump into the lesson 19. And scroll down to web APIs. Earlier, we talked about how a lot of data is represented as JSON files. A lot of the data on the internet, like maybe social media profiles, are kind of stored as such. Right? But not only people's profiles, web pages can be stored as nested dictionaries as well. Right? For example, Wikipedia. Right? Like let me go to the Wikipedia thing real quick. Let me go to Wikipedia and then search up something. I'll just search up lions. So I'm just gonna go to Wikipedia and then search up lions. Right, just an animal. There we go. Right, we have an article here, but how does the underlying representation look like? It looks like a nested dictionary. Right? You might not see it here, but we could pull up some data on it. Right, the back end data kind of looks like this over here. So I just pulled up the back end data. Right, this is a JSON file. It's like a nested dictionary. Right, let me collapse everything. Let me collapse this. Collapse. All right. So imagine this is a dictionary with two key value pairs. Right. The first key value pair is called batch complete, and this is just some back end data for whether or not something was successful. Right, and then the second key value pair is query. Right, it's query and then another dictionary. Right, so let me expand this. Right, okay, I expanded it. Right, query is a dictionary that contains a key value pair called pages. So look at this. Okay, cool. There's another page here. Right, let me expand this, and it's another dictionary. Right, more key value pairs. Right, we've got title is a lion, and then the extract. Right, extract is a fancy way of saying summary. Right, so the summary here is this data here, right? The lion is a large cat, right? You see how it's kind of represented, right? This is the same as over here, right? The whoops, zoomed in too much. Zoom in a tiny bit more. Okay, you see what's happening here, right? This is the extract, the summary of the article. Right? The lion is a large cat of this genus. Right? That's the same thing as this back end data here. So this does look tricky to look at, right? Just try to imagine this as a dictionary, but it's got a lot of layers of nesting. Right? In this case, let me count the layers of nesting. Right? We have one dimension here, right? 2, 3, 4. Right? So we have to dive in 4 different dictionaries in order to access the extract. Right, this is necessary because web pages can be having a lot of content, right? So the more content we have, the more nesting we might have in our data structure. So let's go ahead and download this JSON file. Okay, going back to the lesson on the web APIs. Oh yeah, good question. Is this how people edit Wikipedia information? Not necessarily, actually. People edit Wikipedia information through a wrapper that will modify this dictionary for us. Like if you were to modify the dictionary, I think there's a wrapper down here. Let me see where that. There's like an edit page somewhere. Oh, a wrapper is like, it's like it's doing the work for us. It's giving us like a front end that will access the stuff inside. So there is like an edit page button somewhere. I forget where it is, but if you find the edit page button, it's pretty much wrapping the ability to modify values inside of dictionaries. Right? That's really what it's doing. Okay, so we just saw a JSON representation. Right? You can think of it as here. Right? There were multiple layers. You don't really have to worry about these ones over here, batch complete. I'm not sure what batch complete is. It's probably some back-end thing to verify if an article is successful. But more specifically, we had to dive in multiple nestings, right, in order to access the title and extract. Okay, so let's go ahead and download some data, right? There's a function here that will download these dictionaries for us. Right? So this function is called wikifetch. It takes a string. Right? So whatever string put in here is like searching the Wikipedia. Right? So once again, this function is analogous to going to Wikipedia, right, and then typing in something. Right? So imagine I typed in like California, right, and then press enter. Right? That function is the same thing. Right? It's the same thing. Wikifetch. Imagine we typed in California here, and then it's going to do some work and download that data for us. So let's go ahead and use this function to download data. Right? Like it was called wikifetch. It's called wikifetch, and it takes a single argument. Right? The argument represents the query that we're searching for. Right? Like let's say I were to look up California. Right, so this is saying, hey, Wikipedia, give me data on California. It's just like searching it. So, this does return a dictionary. Right? You can see that in the function here. Right? This function returns a dictionary of data. So let's capture that dictionary into a variable called data. Okay, so I'm going to run this. Cool. Okay, wikifetch is not defined. I forgot to run this function up above. So let me play that. Okay, and I run this. Okay, cool. So we just downloaded data, right? It doesn't have any output, but there is. Let me make another cell and visualize what data is. Jupyter Notebook will show us what the result here is. So let's print it out. Or not print it out, right? If you print it, it's going to be a little unformatted. So I'm just going to leave it as a Jupyter Notebook representation. I'm not going to print it out. Right, there we go. Right, this is the data we just fetched from Wikipedia. It's like a nested dictionary. Right, in particular, there's multiple nestings here. Like let's see the keys on the outer dimension. Like if I were to do a dot keys here, right? This is a dictionary function, by the way. Right, it'll tell us the keys in the outer dimension. So let me do data.keys. Enter. Right, you see how the length of the dictionary is 2? Right, there's 2 things here. In particular, query is the big one. Right, like if I were just look at a plain dictionary, right, you see how query its value is this whole thing right here, right? This whole thing. So we need to look at the query. Right? So let me index the query value. Right? This is saying, hey, access this whole value over here, right? This whole dictionary. So I'm gonna press play here. Okay, there we go. Just press play, and we dove deeper into the data structure. All right, let's say we wanted to dive even deeper to, you know, maybe title or the extract. Right. Well, we have to see what keys are available to us. Right. It looks like there's only one key available to us, which is pages. Right. We can verify this by doing the dot keys. Right. This is gonna display all of the keys on this dictionary. So press keys. Right. See, there's only one key here. So I'm gonna index that pages. Right. This is, if I put pages here in another dimension, this is saying grab the value from the key pages, right? So it's everything after here. Okay, so let me run this. Okay, cool. I just ran it, and we're greeted with another dictionary. If anything, we need to do a couple more layers, right? Like we should probably access this whole value here, right? And this whole value looks like it's using some number, right? This number is pretty much just a page ID, right? It's like every article has like a certain unique identifier, and this identifier happens to be represented by 5407. Right? So we could use that. Right? It is a string 5407. It looks like a number, but it's a string because there's quotes around the side. So let's access that. Right, and there we go. We dove into it. This is our last layer of nesting. This is the last layer, right? If we look at the keys, we're going to see 4 different keys now. Right? One is the page ID. One is I don't know what NS is. We got title, California, and then extract, the summary. Right, so let's look at the keys here. Right, look at the keys, and we see 4 of them. Right, so let's pretend that we were going to access the extract. Right, the extract is the summary. So put extract here, and it should finally return a single string, right? The summary. All right. So yeah, this did look complicated, but all we really did was navigate through a super nested dictionary. So earlier we brought up this representation. There is a representation up here. You can click on this link. It's for Lions. Right, the representation for the Lions webpage. Right, there's a bunch of nesting happening. Right? We had to go into query. We had to go into pages. It's ID, and then the extract. So we dove down multiple layers, and that's kind of why there's so many layers here, right? Query, this gives us a dictionary, and we had to go into pages, gives another one, and we dive deeper into it. Yeah, pretty cool stuff. Once again, we can access multiple things like the title. Right, title gives us California. You know, extract gives us the whole summary. Okay. Okay, yeah, hopefully people are cool with this so far. Okay. Yeah, good question. When is data structures applicable? It's not only applicable for research, but just like organization of data. Like if you were to make a website, typically the website has a back end that stores a lot of information. So you can imagine that the information can be organized in a nested dictionary. Yeah, data structures is just good for storing data. So it's not just for research. It's for pretty much the backbone of the whole internet. Okay. Cool. Hope that makes sense so far. Okay, let me look ahead to see what else we need to do. Let me look at the lab real quick. I might save this for next week. Let's see. Okay, yeah, I think we have enough to do the lab. Let's do it together since we only have like 10 minutes left. But yeah, once again, we're covering web APIs. In particular, we're using Wikipedia as a web API, meaning that we're using the Wikipedia software to download data into Python. In particular, this function lets us download it. Okay, this is going to be some good information for the next homework, by the way. The last homework will be involving this Wikipedia function. So yeah, make sure you're comfortable with navigating through data structures. This last one is kind of hard because of all the nesting. But yeah, just to take this piece by piece again, right, let me take it piece by piece, right? Like data is a large dictionary that contains two keys, right, two key value pairs. So data.keys, right, we're gonna see batch complete and query. Right, so batch complete and then query. Right, we ended up going into the queries because that's where most of the data is stored. Right, so we went into data query. Right, this is going to return us another dictionary, right? This whole thing over here all the way to the end. See all these curly braces at the end? That's how many layers of nesting there are. Right, so we went into query, which gives us that dictionary, right, and we need to dive deeper. Right, in this case, there's only one key to dive in. Right, we see pages. This is the only key in this dimension. Right, so we could look at the keys to verify. Right, see, it's only pages. So we're accessing this pages, which will give us this whole value here all the way to the end. So let's put pages. That'll give us this whole thing. So enter. Right, there we go. Right, and then it looks like there's one key available to us. Right, there's only one key in this dimension, and we can verify that with keys here. Right, see 5407. Right, so we're using that to index 5407. That's going to give us this whole dictionary here, which is our last layer of nesting. Right, in this case, it looks like there are 4 key value pairs here. Right, this page ID, this one, title, and extract. Right, so dot keys. Right, there we go, our final layer of nesting. We can access the title, which is California, and access the summary. Okay, cool. Hope that makes sense so far. It is a little tricky though. Okay, if anything, there is kind of like a hard-coded value here that we can improve on. This 5407, this is a page ID, which is technically hard-coded, meaning that if we were to search for a different article, this key might not work. Right? Like if I were to search for Arizona, right? Arizona. So I'm just going to reload the data. Right? Okay, I just reloaded the data, and if we were to try to access the same exact nesting, right, it's going to give us a key error 5407. Right? That's because we hard coded this, right? So we'd have to kind of find a way to represent this page ID. Right? Like in this case, this page ID is over here, right? This page ID is represented by this number. So yeah, let's kind of find a way to represent this number. It is kind of non-trivial because we're gonna have to do a bunch of, we're gonna have to do some sort of access. Right, so here's the data for Arizona. Right, let's go all the way back. This is data for Arizona. The page ID is different, but we're basically gonna have to dive into the dictionary and grab this number. Right? So imagine that this is no longer hard-coded. Right? Imagine if we had a page ID. Right? We'd have to define this page ID and have that grab this number. So this is the tricky part, right? This is the tricky part because we're going to have to grab this number somehow. Right? How are we going to print this number? Well, we should probably, here, let me comment this out. Right? Like maybe we do need to go into the query, right? So let me go data query, right? My goal is to access this key. Right? So data query, we need to go into pages. So let's go. Almost, yeah. We do need to get this page ID, but this is like inside. So we don't have access to this yet. We got to go deeper. Yeah. I go to pages, right? And then this is the part where it's kind of tricky because we need to go, we don't really need to go into here actually, because the key already represents that name, that page ID. So, we could grab the page ID by grabbing this value, but then we'd end up hard coding this number. Right, we'd end up hard coding this number, and then we'll. Yeah, good question. We can't really put page ID here, right? So this is what it looks like currently. If I were to put a page ID in here, it's not necessarily going to work because there's no key there yet. But we're not inside of that dictionary yet. Right? Basically, the keys that are available to us, right, is this number. So that's why it's kind of tricky. Right? Like it's probably easier just to grab the key inside of this dictionary, right? Like the keys here is this number. So we need to find a way to grab it. Right? The easiest way to grab it is to convert this into a list, right? And then just grab the first element in that list. Right? The reason why I convert to a list is because there could be multiple pages that represent Arizona. Like, there's only one Arizona, but if you search up like an ambiguous term, there's a chance there will be multiple types of pages. So in this case, it's our goal is to access this individual element. Right? Ideally we could just say, hey, grab the 0th element, right? But that's not necessarily going to work because we should convert keys to a list. Right? But basically, we're attempting to use this whole thing as a list, but we can't yet. So we could actually just wrap this in a whole list right here. Right? So this is converting it into a list. So there we go. Right? We have a list of one page ID, and we can grab that first element with the 0 here. Right? So that's finally going to give us the page ID, right? The element inside the list. So then we can store that in page ID, and then finally have this right here. So yeah, that did look complicated. The reason why it was complicated was I kind of blame the designers of the Wikipedia API. The designers of Wikipedia API, for some reason, they organized their data with some sort of redundancy here, and which made it kind of hard to access this inner dictionary. So yeah, that's kind of why it looked a little tricky. Okay, so we did generalize the page ID, meaning we can probably search up any other thing now. Right? Like if we were to look up Japan, right? This is going to refresh our data, and then I'm going to run this, and yeah, there it is. It gives us new data. Cool. So our page ID is properly generalized. There is one problem with this though that we're going to fix later. If anything, you can type in garbage. All right, type in garbage, and let's see what's going to happen. Right, this is equivalent to typing in garbage over here. Right, like if I were to search Wikipedia and type in like some garbage, right, it's equivalent to typing this in, and you're not going to get anything. So let's do that with the API here. Right, type in garbage. Let's see what's going to happen. Right, there we go. I downloaded some data. Okay, let's try to view the summary of that data. All right, there we go. We got an extract error. So we'll fix this error in just a bit. Actually, we could probably fix it right now. right? But basically, we need to probably study the data and see what it looks like. So let me make another cell and study it. All right, let's see what the data looks like. Okay, so we downloaded data, and it looks like we got an error somewhere. It looks like we got a key error on extract. So let's kind of narrow down why. Right, so we went into query. This should be successful. Right, so here, let me see where it failed. Right, so data query. Right, I'm pretty much taking this piece by piece. So data query, that should be successful because there is this whole value. So enter. Okay, and then pages. All right, let's look at pages. So let's go pages here. Right, and this should be successful because there is a key value pair here. Right, like there are two keys available to us. Right, there's the normalized and there's the pages. So we could access this second one. So let me look at the pages. Right, and it looks like there is a -1 here. So the page ID ended up being -1. So yeah, that's over here. So it ended up being -1 as a string. So that was successful. But then we tried accessing the extract. Right, you see how there's no extract here? Right, this is our dictionary. So we're trying to get extract, and yeah, we get the same thing. So you might be able to do some protection here, like basically we should check this dictionary to see if extract is in there, right? Like one way you could do some sort of protection is by doing like a if extract in this outer dictionary, right? If it's inside the outer dictionary, then we can go ahead and print the extract. Right? So this is protecting us. So if it does exist in the outer dictionary, then access that. Right? Else we could do something like print a no summary. So this is a little safer. Right? We're pretty much checking this right here. We're pretty much saying extract in, right, which ends up being false. Right? So since that's false, it should protect us over here and print no summary. So let's test it. Right? See, it says no summary. Okay, so yeah, once again, we made some protection, so we can type in like California. The extract should exist, so it's going to print out that California exists. But when we type in some garbage, right, the extract shouldn't exist there, so it's going to print no summary. Right, just a bit of protection. Okay, cool. Okay, we're about 1 minute over time. So we didn't have enough time to do this lab, the lab 19 on part 2. I think folks should actually have enough to get this done. Right, if folks don't mind giving it a shot to get part 2 done, it should be possible because we actually already just did all of this in the end of the lesson. Right, the rest of the lab is really asking you to do the same thing. Right, it's saying on part 2, use the Wikipedia API to fetch the summary. So yeah, we already did this. So yeah, go ahead and see if you can implement it on yourself. And feel free to let me know if there's any problems with it. But yeah, this is some good stuff. It's going to get us ready for the last assignment. Okay, thank you all for coming. And have a great week. Next week we'll be doing object-oriented programming. Right.